Antarctica, a name that conjures images of immense, blinding white. It is the coldest, driest, and windiest place on Earth, a colossal landmass shrouded in ice. This frozen desert holds the majority of our planet's fresh water. Beneath this facade lies a complex, mysterious world, a realm of profound silence broken by the howl of the wind. What secrets could such a place hold? What forms of life might persist in total darkness? The Antarctic ice is not merely a passive covering. It moves, it grinds, it melts, and it refreezes. Beneath its bulk, geothermal heat provides residual warmth. Liquid water can exist far below the freezing point. In these hidden pockets, mysteries of Antarctica unfold. For many years, our understanding of Antarctica's subglacial world was limited. Recent decades have brought remarkable advances. The silence beneath the ice, it turns out, is not absolute. There are stirrings, whispers of activity from a world long hidden from the sun. Reports have begun to emerge of vast lakes of liquid water and interconnected river systems. The discovery of these subglacial aquatic systems has opened an entirely new frontier in polar science. Where there is liquid water, there is the potential for life. Could it be that Antarctica's hidden waters also harbor unique ecosystems? The initial findings suggest this is not just a possibility but a reality. The information emerging from beneath Antarctica's ice is profoundly transformative. Each discovery reveals a dynamic, interconnected continent. We stand at the threshold of a new age of exploration, unlocking secrets about Earth's history and life's resilience. These revelations compel us to see Antarctica anew, a place of hidden dramas and future surprises. Isolated ecosystems offer a unique natural laboratory, studying life in extreme conditions, insights into life's origins and potential on other planets. The ongoing research carries urgency. Antarctica is on the front line of climate change. Melting ice impacts sea levels and reveals hidden environments. What might be lost before it's fully discovered? This adds urgency to our quest for knowledge. Exploring Antarctica's hidden realms is more than scientific. It's a journey into our planet's past and future. Stories from beneath the ice challenge our assumptions. With each advance we learn more, heralding a new chapter in understanding Earth. The year is 2025. January brings summer to Antarctica. On the George VI ice shelf, tensions grow. The ice shelf groans under its weight. A section prepares for a grand severance. Then, it happened. Iceberg A84 was born. A floating island breaking away. The sound echoed through ice and water. A84's detachment signaled change. Ice shelves act as colossal dams, a delicate balance of forces. A84's break signaled equilibrium change, an opening to a hidden realm. This event did not go unnoticed. Satellites registered the change. The RV Falkor was diverted to explore newly exposed waters. What secrets lay on the seabed? A rare chance to study a pristine environment. The RV Falkor's journey to the A84 calving site was swift. Upon arrival, the scene was stark and beautiful. The water was dark and cold. Scientists prepared their ROVs equipped with cameras and lights. Their destination was the seabed, 700 meters below. As the ROV descended, astonishing images emerged. The anticipation on board was palpable. In the darkness, something extraordinary emerged. Patches of unexpected color appeared. It was a moment of profound revelation. The initial discoveries were startling. A thriving community was unveiled. Delicate coral stood rooted to the rocks. Sponges dotted the landscape, filtering water. These were not the sparse organisms expected. It was an oasis of life, vibrant and isolated. The filter-feeding communities were a puzzle. How did they sustain themselves? What were their food sources? These ancient organisms spoke of stability. The detachment of A84 revealed a secret garden, challenging assumptions about life's tenacity. Among the corals and sponges, the cameras of the ROV soon focused on more mobile yet equally surprising inhabitants. The scientists watched, transfixed, as a creature of exquisite fragility and ethereal beauty drifted into view. It was a Galateuthis glacialis, more commonly known as the glass squid. This remarkable cephalopod, perfectly adapted to its deep-sea existence, seemed almost an apparition. Its body was largely transparent, a ghostly silhouette against the ROV's lights. The glass squid, with its large intelligent eyes, navigates the crushing pressures and icy temperatures with an elegance born of millennia of evolution. Its near invisibility is a testament to the strange and wonderful ways life contorts itself to survive in extreme conditions. Observing it in this newly exposed habitat, a place previously sealed by the George VI ice shelf, provided invaluable data. It confirmed that complex life, not just microbial communities, could indeed persist and even thrive in these subglacial marine environments, a world away from any direct influence of the atmosphere or sunlight. The discovery of this entire ecosystem, from the stationary filter feeders to the elusive glass squid, has profound implications for our understanding of Antarctic biodiversity. It suggests that the vast areas beneath Antarctica's numerous ice shelves, previously thought to be relatively barren, could in fact harbor significant undiscovered communities. Each ice shelf could be concealing its own unique assemblage of species, its own hidden biological secrets. This single calving event has multiplied the potential area where such life might be found, hinting at a far richer, more complex Antarctic marine realm than ever imagined. This newfound knowledge also brings with it a sense of responsibility. These ecosystems, having evolved in extreme isolation and stability over vast timescales, are likely to be incredibly sensitive to change. The very event that revealed them, the breaking away of the ice, is linked to broader climatic shifts. As Antarctica continues to respond to a warming world, these hidden oases face new uncertain futures. Their discovery is not just a triumph of exploration, but also a poignant reminder of the fragility of life in the face of planetary change, urging further study and protection. Antarctica guards secrets within its continental heart. Deep beneath the ice lies a hidden world. Vast subglacial lakes exist miles below the surface. Hundreds of these lakes form an immense hydrosphere, a water world concealed from sunlight for eons. Significant lakes, some rivaling Earth's Great Lakes. Liquid water in a ferociously cold environment. Geothermal heat and colossal pressure keep them liquid. Earth's geothermal heat warms the ice base. Colossal pressure lowers the melting point of water. Lakes persist, cradled between bedrock and glaciers. Scientific curiosity surrounds these subglacial lakes. Each lake is a potential time capsule. Unique life forms may have evolved in isolation. Exploring these systems without contamination is a challenge. Lakes Vostok and Enigma offer clues to life in extremis. They are the focus of intense research. What narratives are locked within their waters? What biological marvels have adapted to darkness? We are delving into the definition of life, questioning the limits of where life can flourish. Lake Vostok is the titan among Antarctica's known subglacial lakes. Buried nearly 4 kilometers beneath the East Antarctic ice sheet, its surface area is comparable to that of Lake Ontario. Its discovery, pieced together through decades of seismic soundings and airborne radar surveys, was a landmark moment in polar science. Scientists estimate its waters have been sealed off from Earth's atmosphere for at least 15 million years. Traces of microbial life were detected, microscopic organisms that had somehow persisted in this dark, cold, high-pressure world. The findings from Vostok hint at a biology operating on principles subtly different from our own. While Vostok captured global attention with its sheer scale and ancient isolation, other subglacial lakes, such as the aptly named Lake Enigma, have added further layers to the unfolding mystery. Lake Enigma, though perhaps less vast than Vostok, presents its own compelling narrative about the tenacity of life. Reports emerging from its exploration, as detailed by sources like Muy Interesante, speak of microbial ecosystems that seem to push the boundaries of what biologists thought possible, challenging established doctrines of life's fundamental requirements and operational modes in unexpected ways. The conditions within Lake Enigma, like other subglacial aquatic environments, are undeniably extreme. Perpetual darkness reigns, eliminating any possibility of photosynthesis, the process that underpins most life on Earth's surface. The pressure is immense, hundreds of times greater than at sea level, a force that would crush most familiar organisms. The water chemistry itself can be unusual, influenced by long interaction with the surrounding bedrock and the slow melt of the overlying glacier. Yet within this seemingly hostile soup, life has not only survived, it has established intricate, functioning ecosystems, a testament to its inherent drive. The key to understanding life in Lake Enigma, and indeed in many such subglacial systems, lies in chemosynthesis. Instead of sunlight, microbes in these dark waters derive energy from chemical reactions, metabolizing minerals and dissolved gases leached from the rocks or trapped within the ice. These chemosynthetic organisms form the base of the food web, primary producers in a world without light. Their metabolic pathways are often novel, their genetic makeup reflecting eons of adaptation to an existence utterly alien to our sun-drenched perceptions, revealing an alternative blueprint for sustaining biological communities. The revelations from Lake Enigma wonderfully complement and expand upon the findings from Lake Vostok. They demonstrate that the presence of microbial life in subglacial lakes is not an isolated fluke, but potentially a widespread phenomenon across Antarctica's hidden hydrosphere. More than that, they reveal a surprising diversity in how these ecosystems function, how life has ingeniously harnessed the scant resources available in these profoundly challenging settings. Each newly studied lake seems to unveil another facet of life's remarkable adaptability, painting a picture of a vibrant, albeit hidden biological frontier deep beneath the Antarctic ice. The combined discoveries from Lake Vostok, Lake Enigma, and other less explored subglacial water bodies are fundamentally reshaping our understanding of Antarctica. This is no longer just a continent of ice but also a continent of water, a vast interconnected system of lakes and rivers hidden from view. These findings suggest that a significant biome, a unique and ancient realm of life, has been thriving beneath our feet, largely unnoticed until recent technological advancements allowed us to peer beneath the frozen veil. This hidden biosphere dramatically expands the known extent of life on our planet. These remarkable ecosystems, flourishing in conditions of extreme cold, crushing pressure, and perpetual darkness, compel a profound re-evaluation of the limits of habitability. For centuries, our search for life, both on Earth and beyond, has been largely guided by conditions familiar to us on the surface. Yet, Antarctica's subglacial realms demonstrate that life can persist, and even diversify, in environments previously dismissed as utterly barren. This resilience, this sheer tenacity of biology to exploit every available niche, forces us to broaden our definitions of what constitutes a life-supporting environment. The implications of these Antarctic discoveries extend far beyond our own planet, resonating deeply within the field of astrobiology. If life can thrive in liquid water trapped beneath kilometers of ice on Earth, then perhaps similar environments on other celestial bodies are not as inhospitable as once believed. Icy moons in our outer solar system, such as Jupiter's Europa or Saturn's Enceladus, are now known to possess vast subsurface oceans beneath their frozen crusts. Antarctica's subglacial lakes serve as invaluable terrestrial analogs, providing natural laboratories to study the potential for life in these distant alien seas. The exploration of Antarctica's hidden waters is still in its infancy. Hundreds of subglacial lakes remain untouched, their secrets locked away. Each one is a potential treasure trove of new biological discoveries, holding clues to the evolution of life, the history of Earth's climate, and the sheer adaptability of organisms. The ongoing quest to understand these dark, cold realms is a journey into the unknown, continually challenging our perceptions and expanding our appreciation for the intricate, often surprising, tapestry of life that our planet supports, even in its most concealed corners. Antarctica, a continent defined by its ice. Intriguing whispers emerge from deep below its frozen surface. Could ancient feet have once walked this land? Advanced technologies now pierce the icy veil. They hint at order, at possible design beneath the ice. The ice asks us to listen intently and to always wonder. The primary instrument in this deep search is ice-penetrating radar. This technology transmits radio waves into the ice sheet. Waves reflect off different materials and bounce back. Scientists construct detailed maps from these echoes. Unexpected anomalies in data suggest intriguing patterns. These patterns sometimes resemble human activity. Interpreting this data is a challenging task. Scientists must meticulously analyze and cross-reference. Disentangling potential ancient signals requires patience. The detection of these anomalous subglacial patterns has ignited a fascinating debate. Are these formations evidence of long-lost civilizations or natural geological features? Some ancient maps, like the Peary Race map, show Antarctica's coastline before it was covered in ice. Proponents suggest these maps could be from a seafaring civilization with advanced knowledge. However, direct archaeological proof remains elusive, buried deep beneath the ice. The mainstream scientific community is skeptical, citing Antarctica's ice coverage for millions of years. They propose geological explanations for the radar anomalies. Thus, the civilization conundrum in Antarctica persists, fueled by intriguing but inconclusive data. Whether these radar echoes are ghosts of ancient cities or geological chants, they push the boundaries of our knowledge. The quest to understand these Antarctic secrets enriches our comprehension of Earth's complex history. The McMurdo Dry Valleys of Antarctica present a stark, alien landscape. Here, colossal glaciers flow, carving paths between barren rocky peaks. The air is incredibly dry and the winds are relentless, creating one of the most extreme deserts on our planet. Yet within this lifeless expanse, a startling phenomenon captures the eye. From the snout of the Taylor Glacier, a cascade of deep, blood-red water emerges. This crimson outflow spills onto the ice-covered lake surface, creating a shocking contrast. This is Blood Falls. For decades, its origin was a profound enigma. Early explorers were mystified by the vibrant hue. Initial theories about the red color varied, with some speculating it was due to algae. However, the true explanation would prove to be far more ancient. The falls hinted at a unique subglacial environment, one trapped and isolated for an immense span of time. The mystery of Blood Falls beckoned scientists to look deeper. They urged them to understand the forces that could paint the Antarctic landscape with such a dramatic and persistent crimson signature. Blood Falls remains a vivid, visceral display, demanding our attention. The true nature of Blood Falls remained a puzzle for many years. Researchers collected samples from the saline iron-tinged outflow. They deployed sophisticated instruments to probe beneath the Taylor Glacier. Slowly, a picture began to emerge of a deep, hidden source. Beneath the Taylor Glacier lies a subglacial body of water, an ancient hypersaline lake. This water body has been trapped for an estimated 1.5 to 2 million years. The distinctive red color of Blood Falls is a result of geochemistry. The trapped subglacial brine is incredibly rich in dissolved iron. When this iron-rich, oxygen-free water seeps out, it encounters the oxygen in Earth's atmosphere. This exposure triggers a chemical reaction, oxidizing the iron and staining the water blood red. This process reveals a hidden hydrological system operating in complete darkness. Blood Falls acts as a natural tap, providing a rare window into this otherwise inaccessible environment. Each pulse of red water brings clues from a world isolated for geological timescales. It tells a story of deep Earth processes and the slow interaction between rock and liquid. Blood Falls remains a profound geological riddle, staining the ice with its persistent rusty tears. The discovery of the iron-rich anoxic brine beneath Taylor Glacier opened up a tantalizing possibility: the existence of life. Could organisms survive in such an extreme and isolated environment? The answer is yes. Analysis of the water emerging from Blood Falls revealed a unique microbial ecosystem. These microbes represent a lineage that has been evolving in isolation for potentially millions of years. They are chemosynthetic organisms, deriving energy from chemical reactions involving iron and sulfur compounds. These bacteria breathe iron instead of oxygen, sustaining themselves in perpetual darkness. The survival strategies of these organisms are a testament to life's incredible resilience. They redefine the boundaries of where life can be found and what it requires to endure. The Blood Falls ecosystem serves as a natural laboratory for understanding life in extreme environments. It also acts as a compelling analog for potential habitats on other planets or moons. Antarctica's Crimson Secret expands our vision of where life might exist beyond our own world. The journey beneath Antarctica's icy mantle has been one of profound revelation. We have ventured from vibrant marine gardens to ancient sunless waters of subglacial lakes. Each discovery has chipped away at the continent's enigmatic facade. Antarctica reveals itself as a realm of astonishing dynamism and unexpected complexity. The life encountered in these extreme havens speaks volumes of biological tenacity. The microbes of Lake Vostok and the ecosystems within Lake Enigma rewrite the rules of survival. The crimson tears of Blood Falls tell a powerful story of organisms breathing iron in an oxygen-starved world. These findings reshape our view of Earth's intricate history and its ongoing biological narrative. The potential for ancient structures beneath the ice ignites the imagination. The subglacial ecosystems are living museums, preserving biological lineages and processes. Antarctica is an archive of planetary memory, holding echoes of lost worlds and forgotten epochs. The ice is a keeper of immense secrets, divulging them slowly to those who listen with patience and the right tools. Looking forward, the depths of Antarctica promise further revelations. The continued melting of Antarctic ice due to climate change presents a dual reality. It may expose more subglacial environments, making them accessible to study. However, it also poses a threat to their stability and pristine nature. The impact of these discoveries reverberates far beyond our planet. The resilience of life in subglacial lakes provides compelling analogs for astrobiologists. Antarctica serves as a vital proving ground for the search for life beyond Earth. Ultimately, Antarctica remains a potent symbol of the Earth's enduring mystery. The quest to understand Antarctica's hidden realms is an ongoing narrative. The depths beckon, promising that the greatest discoveries may still lie hidden, waiting for the patient, persistent seeker.